Hello my dear students, I am Mukesh Tilwani, Assistant Professor in MLV Test and Engineering College, Bhilwara. My subject is manufacturing processes and the topic for today is electric arc welding. This is a lecture 1 of electric arc welding in which we are going to discuss the principle of arc. First, the basic circuit of arc welding. This is a basic circuit of arc welding in which this is a DC generator, power supply, and the voltmeter, ammeter, and the electrode holder for holding the electrode, and this is a workpiece. The arc is generated between the electrode and the workpiece due to the positive and negative terminal. If we give the power supply with the help of V upon I, V is a voltage, I is a current. With the help of calculating the power with the help of V upon I, then we give the power supply to the electrode so that electrode is positive and workpiece is negative. Between positive and negative terminal, the arc is generated. With the help of this arc, we weld the material. Now the principle of arc. An arc is generated between the cathode and anode when they are touched to establish the flow of current and then separated by the small distance. An arc is generated between two conductors of electricity, cathode and anode, by considering the direct current, which is also called a DC. When they are touched to establish the flow of current and then separated by a small distance, an arc is a sustained electric discharge through the ionized gas column, which is also called the plasma, between the electrodes. 65 to 75% heat is generated at the anode. In an arc welding, 65% to 75% heat is generated at the anode by striking the electrons. If DC current is used and the work is positive, which is the anode of the circuit, positive anode of the circuit, then the condition is known as straight polarity, which is also called as SPDT, straight polarity direct current. When the work is negative and the electrode is positive, which is called the reverse current polarity, which is also called as the RPDC. The full form of RPDC is reverse polarity direct current. SPDT condition is preferred. Why? Due to generated heat is liberated at the anode of the SPDT, condition is generally preferred. DC arc welding can maintain stable arc and preferred for the difficult to task such as overhead welding. For stable arc, the gap should be maintained. As the electrode melts, the arc length and the electrical resistance of the arc path will vary. To maintain the stable arc and the satisfactory welding condition, the electrode must be moved toward the work at the controlled rate. Manual arc welding is done with the shielded, which is also called covered electrodes. Manual arc welding is almost performed with the sheltered arc welding. Continuous bare metals wire can be used as the electrode in automatic or semi-automatic conditions. Non-consumable electrode such as the tungsten is not consumed by an arc, and the separated metal wire is used as a filler. In the second family of arc welding process, the electrode is made of tungsten, which is not consumed by the electrode except by the relatively slow vaporization. And these non-consumable electrode processes, a separate metal wire is used. To supply the filler metal. There are three modes of metal transfer during the arc welding, which is the globular, and second one is spray, and third one is short circuit. These are the diagram of the three modes of metal transfer during the arc welding. This is a globular, second one is spray, and third one is short circuit. This is a way of that metal transform in the arc welding. Major forces take part in the metal transfer. First one is gravity force, second one is surface tension, third one is electromagnetic interaction, third one is hydrodynamic action of plasma. With the help of these four forces, the metal transfer takes place. Now I'm discussing the gate question. In DC current, DC welding, the straight polarity, that is the electrode negative, result in first one is lower penetration, lower deposition rate, less heating of workpiece, a small weld pool. Here, due to the lesser amount of heat at the electrode, because of a straight polarity negative electrode, the lower disposition rate is obtained. Arc welding equipment, droopers, constant current welding machine. The constant current welding machine is good for the manual arc welding, and the constant voltage machines are good for the automatic welding. There are two types of machine possible. One is OCV, which is called open circuit voltage, and second one is SCC, which is called short circuit current. This is a characteristic machine. Figure the machine with the different setting. This is a graph of the volt versus ampere graph at 80 volt setting, and second one is 50 volt setting per second. And second diagram is characteristic curve of a constant voltage arc welding machine. The formula for characterizing the arc welding is there is a relation between OCV and SCC, which is a V upon OCV plus I upon SCC is equal to 1. From this diagram we get the graph this. If the short circuit current is 0, then OCV will be voltage will be open circuit voltage. If the open circuit if the velocity is 0, then the current is short circuit current. Arc welding requires a large electric current, often in the range of 150 to 1000 ampere. The load voltage is usually between 30 and 40 volt, with the actual voltage across the arc welding from 12 to 30 volt. To initiate a weld, the operator strike the electrode and start arc. To initiate a weld, the operator briefly touches the tip of the electrode to melt the workpiece and quickly raise it to a distance that will maintain a stable arc. The intense heat quickly melts the tip of the electrode wire, the coating, and the portion of the adjacent base metal. Thank you so much. For today, I am closing my lecture. In next lecture, I will discuss continue discuss about the arc welding. Thank you so much.